All right, in this Unit 3 review, keep in mind what you're doing in numbers 1 through 3. In other words, read the directions. It just says to find the slope, doesn't it? Then just do that. Just find the slope. Do not write the equation in slope-intercept form. You're just taking these 2 points and finding the slope. To do that, in number 1, use your formula, y2 minus y1 over x2 minus x1, 5 minus 9 over negative 1 minus 4. The double negative cancels, and you're left with 4/5. In number 2, you have negative 8 over positive 8, which is negative 1. And in number 3, anytime you have 0 in the numerator, the answer is 0. Now in numbers 4 through 10, here we're writing the equation in slope-intercept form. So do that. How do you do that? Write the equation in slope-intercept form by finding the slope first. Well, it's 2. I don't care. We know what it is. Write it down. That's step A. That's finding the slope. What's step B? Find the y-intercept. It's negative 5, which gives you an equation of y is equal to 2x minus 5. In number 5, the line passes through the points negative 2, 2, and 2, 10. Well, find the slope. Use your formula, y2 minus y1 over x2 minus x1. Plug in the right coordinates. That means 10 minus 2 in the numerator and 2 minus negative 2 in the denominator. You get 8 over 4, which is 2. The y-intercept isn't given, so you're going to have to figure it out. To do that, you use y equals mx plus b. I'm plugging in the first point here, negative 2, 2. So I put 2 in for the y. I have 2 for the slope. I have negative 2 for x plus b. That means I have 2 is equal to negative 4 plus b. Adding 4 to both sides, you get b is equal to 6. Your equation, y is equal to 2x plus 6. Now remember, you can always pause the video at any time. If you need to get caught up or whatever the case might be, you can pause this and come back to it later. In number 6, we want the equation of the line that passes through these 2 points. Well, you have to use your slope formula to find the slope of the line that goes through those 2 points. And you get negative 2 over negative 1, which is positive 2. Then you have b. Actually, it's given here. Are you catching this? Whenever x is equal to 0, you have your y-intercept, which is negative 3. Now, if you need to, you can go ahead and plug everything into y equals mx plus b. You're still going to get b is equal to negative 3. But then you get your equation, y is equal to 2x minus 3. And in number 7, I know the slope is given. I don't care. Write it down. M is equal to 3/4. In order to find b, because it's not given, you need to start with y equals mx plus b. Please do that. Then you can plug in the coordinates, the negative 4 or 5, into the equation, along with the slope being 3/4. Solving for b, b is equal to 8. You get your equation, y is equal to 3/4 x plus 8. How are you doing so far? Now in number 8, we still need to write the equation in slope-intercept form. Well, in order to do that, you need the coordinates of 2 points. Well, think about it. The x-intercept being negative 2, the coordinates for that point would be negative 2, 0. The y-intercept being 6, you have the point 0, 6. So plug this into the formula, and you get 3. The y-intercept is given. Write the equation. In number 9, your slope is 5. Write it down. It's the difference between thinking you know and knowing you know. Prove to us that you know that the slope is 5. Write it down. Don't make us guess. Don't make your teacher guess as to whether you know what's going on or not. Prove it. Write it down. Write down the y-intercept is 2, b is equal to 2. Write your equation, y is equal to 5x plus 2. And number 10, a line that passes through the points 2, negative 2, and 2, 7. Well, we have to find the slope, right? 7 minus negative 2, right? Over 2 minus 2. 9 over, oh, wait a minute, 9 over 0. What does that mean? Well, it means there's no slope. Well, think about this. Think about this for just a second. If there is a y, then there is a slope and a y-intercept, if there's a y. Meaning you have to have a y in order to have the slope. If there is no slope, and think about that, what does that say? If there's no slope, then there is no y. You have to have one in order to have the other. So if there's a y, there is a slope. If there's a y, you have a y-intercept. If there is no slope, then there is no y. And if there is no y, then what is there? Well, then you have to have an x. Okay, so if there's no y, if there's no slope, there's no y. If there's no y, it has to be an x. Here's what I'm getting at. Let's go back to our problem. Since there's no slope, there's no y-intercept. Step B we don't do because there is no intercept here, no y-intercept. And since there's no slope, there's no y. Since there's no y, what is there? There is an x. I still need to have the equation of the line. X is equal to what? 2. So there's your equation of the line. X equals 2. In number 11, add 2x to both sides, divide everything by 3, and you get y is equal to 2/3 x plus 4. In number 12, you can't do anything if there are parentheses in a problem. They must be eliminated first. To do that, you have to use the distributive property, right? So negative 2 times x, negative 2x. Negative 2 times 4 is negative 8. And then you can subtract the 6 from both sides. Negative 8 minus 6 is negative 14, so y is equal to negative 2x minus 14. Now, number 13, we're going to write an equation in slope-intercept form. Always read the directions, please. Write an equation in slope-intercept form of a line that is parallel. Circle that. Why? Because parallel lines have slopes that are the same. What's the slope of our original line? The original line, the slope is 5. I get that from right here, right? Well, our new line, what's the slope of it? Well, it's the same. It's 5. So we're going to be using this same slope. Am I going to be using this old y-intercept, the original y-intercept? No. I need to find a new one. How do you do that? Well, you're going to start with y equals mx plus b. You're going to plug in the coordinates. Negative 6 is equal to 5 times 4 plus b. Negative 6 is equal to 20 plus b. Subtracting 20 from both sides, b is equal to negative 26. So you have the line y is equal to 5x minus 26. Now we have perpendicular. What does that mean? Well, if you've been in my class, you'll know that it means flip and change. What we're going to do is we're going to take the original slope, which is what? The original slope is -3/2. Our new slope for the new line, it'll be what? That's where the flip and change comes in. You flip the fraction over and change the sign. Since it's negative, it'll be positive. Flipping it over, you get 2/3. We're going to be using this. Do we need to use this old y-intercept? No, that's out. We're looking for a new y-intercept. How do you do that? You start with y equals mx plus b. Plug in the -2 for the y, the 2/3 for the slope, the -2 for the x plus b. -2 is equal to, well, fraction. Oh my goodness. Here's where we're going to run into trouble, right? Wrong. Plug this into your calculator. -4/3 plus b. Well, now it's even more trouble, right? Wrong. What do you need to do to both sides? Add 4/3. Well, what's -2 plus 4/3? You end up with b is equal to -2/3. So you get y is equal to 2/3 x minus 2/3. In number 15, George drove his car along the highway. The following graph shows his speed over a period of time. Describe, interpret, what is happening in this graph. Be sure to include all the changes in his speed during the drive. Meaning this, class. Now, usually when we have two things that we're comparing here, like for example in this one, we have speed over a period of time. Time is going to go on the x-axis. What's happening to his speed as he does that? Well, we talked about how we can put points at these changes, right? And let's go ahead and label these points A, B, C, D, E, and F. From A to B, what's going on? Well, what's happening to his speed? He's increasing speed, right? So he's gaining speed. From B to C, what's going on? Is he stopped here? No, we're talking about speed here. So what's happening to his speed? Is the speed changing? No, he's maintaining his speed. It's all about speed here. What's happening from C to D? That's right, he's slowing down. Probably, I don't know what's going on. Somebody cut in front of him and he had to slow down a little bit, right? And then what happened? He goes from D to E. From D to E, he's gaining speed. He's speeding up, right? And then from E to F, what's he doing? That's right, he slows to a stop. All right, if the Cosby family is driving on vacation and they go 560 miles in 8 hours, write an equation that describes the distance driven with respect to time. That means use your formula, D is equal to R times T. Distance is equal to rate times time. Well, what is the rate? Well, rate means miles per hour. Well, how many miles? 560. How many hours? 8. How fast is it going? 70 miles per hour. So this is his speed. So we're going to plug this into the formula. Here's the equation that we're looking for. D is equal to, the distance is equal to 70 times T. 70T. That's the equation. That's the answer we're looking for here. Now we're going to graph the equation. So I need to label my axes, and I'm going to put time on the bottom axis, the x-axis. So I'm going to label this 2, 4, 6, 8, and 10 hours along the bottom. And then I'm going to count by 200s along the y-axis. That's your miles driven. So 2, 4, 6, 8, 10, 1,000, and then 1,200 miles. Now, we need to graph this. So what this means is that, well, let's put a couple of points here. At 0 miles, we're going to be 0 hours, we're going to be driving 0 miles. Doesn't that make sense? And then at 8 hours here, it's 560 miles. So here's 400. Here's 500. 550 was halfway between, so 560 will be a little bit more than that. So right about in there, right? So I'm going to graph that line. And it'll look kind of like that. So there's the graph of this relation. Now, the next question is, how long would it take him to drive 1,050 miles? Now, 1,000 is here. Here's 1,100. Here's 1,050. What I would like to do, but it gets off my graph here, so this may not be the best thing to do. But if I were to take that over to there, well, let's see now, let's put that right about at 1,050. And if that takes it over to my graph here, then if I were to follow that down, but again, it takes me off the graph, so it's not going to be so easy to do this. But we can kind of get an idea that it's going to be, here's 10, here's 12, 14, and it's going to be somewhere probably between 14 and 16 hours here, right? Well, the other thing we could do is to take 1,050, since those are our miles, put that in for the distance, the miles. So 1,050 is equal to 70 times t. Divide both sides by 70. And what do you get for the t, for the time? So go ahead and take that and plug it into your calculator. And doesn't that give you 15 hours? And isn't that what we said, that it looks like, according to our graph over here, that it's going to be somewhere between 14 and 16, and I would say we were pretty dead on there. So the time that it takes to go 1,050 at 70 miles an hour is 15 hours. In number 17, we're going to go to positive. Now, this is an inequality, so remember, it's either going to be dotted or solid. This is going to be dotted. We're going to be shading above or below. It says less than, so we're going to be shading below. So graphing the line, we go to positive 1 on the y-axis. We're going to rise 1, run 2, and here's our line. Make your dotted line. And then we're going to shade what? Above or below here? Right, it's less than, we're going to do below. So anything in this shaded portion down here will satisfy that inequality. In number 18, we're merely graphing these. The y-intercept is -2, the rise over run is 1, your slope is 1, so there's your line. Y is equal to x minus 2. Number 19, we have to solve for y first. So we're going to subtract 2x, get -2x plus 3. You end up with a negative y, though. And dividing by, remember, dividing by -1 only does what? Changes the sign. So instead of -2x plus 3, we're going to have positive 2x minus 3. And you go to -3 on the y-axis, rise 2, run 1. And in number 20, you're going to subtract 6x first, get -6x minus 12. When you divide everything by -2, you get 3x plus 6. Now you're going to start at positive 6 on the y-axis, but when you rise 3 and run 1, you don't know exactly where that's going to be because you're going to be off the graph, so you go down 3 and left 1, and there's your line, y is equal to 3x plus 6. Make sure you use a straight edge and take your lines all the way across the graph. Thank you very much. Next problem. Whenever you're taking a multiple choice test, try to eliminate any of the possible answers that you can. Since the shading is below the solid line, solid means it's going to be underlined, so all of these inequalities are good to go. Any of these could be it because it's equal to. The solid line means it's going to be equal to. But because it's shaded below, that means less than, doesn't it? So we can eliminate B because that says greater than. All right, let's look at our line again. What's the y-intercept? -2. So that eliminates A. So our choices are C and D. What's the slope of this line? Is it +2 or is it +1/2? Well, because it looks like it's going to rise 2 and run 1, that's 2 over 1. D would be your answer. Number 2, write a linear equation to model the following situation. Tanning Club membership costs $25 for the initiation, plus $15 per month. Remember to look for that word per. Per, each, speed, rate. These all give you the what? The slope. That number right there, that's the slope. That's the number that's being taken times x. So we can eliminate A because it's the 15 that needs to be taken times the x. Now, if we have 0.15 and then the 25, that means 15 cents. That means $25. So we're not talking 15 cents, we're talking $15, so that would be out. And the membership costs $25 for the initiation fee, right? That's a positive 25. B is your answer. Find the slope of the line graphed. Well, it's going uphill, which means it's positive, meaning B and D are out. Your only choices here are A and C. Find any 2 points on the graph, like here and here. That's a rise of 3, a run of 4, 3/4. C. Write the equation of the line through 6, 5, and -2, 3. In number 24, write the equation of the line that goes through these 2 points. Well, you got to find your slope first, and it turns out to be 1/4. Well, look at this. The only response that we have is 1/4, so it must be D. And in number 25, use the distributive property on the right side. You get -1/3 x plus 2. Adding 1 to both sides, -1/3 x plus 3 is the answer C. Write an inequality to represent the following situation. Tickets for the play cost $4 per child. That per means we're going to be multiplying 4 times the child. This per means we're going to be taking 5 times the adult. They need to make at least. What does at least mean? It means greater than or equal to. So 4 times the x plus 5 times the y. We're going to say the child is x. The adults are y, so 4x plus 5y has to be greater than or equal to 2400, D. Which equation is graphed? Well, first of all, it's going downhill, so it can't be A or C because it means it's got a negative slope. Is the y-intercept positive 3 or negative 3? Well, it's positive 3, so the answer is B. Number 28, find the slope of the line through the points 2, 3, and 2, -3. Well, use your slope formula. You're going to be taking -3 minus 3 over 2 minus 2. -3 minus 3 is -6. 2 minus 2 is 0. So is this 0 or is it undefined? And anytime you have 0 in the denominator, it's undefined. In number 29, which ordered pair is not part of the solution set? About the only way you can tell on this, class, is just to simply plug in the coordinates of each point into this inequality. And you ask yourself, is 6 minus 2 greater than 6? No. Is 6 plus 0 greater than 6? No. How about in C? We're going to plug in 0, -4. We plug the 0 in for the x, the -4 in for the y, and we get, is -8 greater than 6? No, it's not. But when we do D, when we plug in 3, 1, we get 9 plus 2. Is that greater than 6? Yeah, so that's our answer, D. Write a linear equation to model the following situation. Wants to lose 5 pounds per week, huh? All right, she weighs 416 and wants to lose 5 pounds per, oh, there's that per again. What's that mean? That's your slope. So y is going to be equal to, now if the slope comes first, that and this is the number that goes with the x, because that's the slope, right? The per number is your slope, so the 5 is the slope. But we're trying to lose those pounds, though, right? If we just said 5x plus 416, that would mean we're trying to gain 5 pounds per week. We don't want to do that. And we don't want to gain 5 pounds. Well, we're not starting out at negative 416 pounds, right? I mean, that's a positive 416, isn't it? All right, so we need plus 416, but how can we show that we're losing 5 pounds per week? Let's make it negative. So that's going to be negative 5x plus 416. There we go, C. And then when you go to name the ordered pairs, B would be at 1, negative 2. It's quadrant 4. Negative 4 is 0 for O. That's none. You'll write none. It's on an axis. You write none. T is at 0, negative 4. Look at the difference between O and T. These are two different points. Negative 4, 0 for O, 0, negative 4 for T. They're both at, not in a quadrant. H is at negative 2, 4, quadrant 2, and then A is 3, 3, quadrant 1. In number 32, we need to know what the domain is of a relation. The domain is the numbers we're using for the x's. So let's look at negative 4. Let's look at negative 3. Let's look at 3. Now it's listed twice. Do we put it down twice? No. I just want to know what are the different numbers that we're using, and we're using a 3. Then we're also using 4 in the domain. The range will be the set of numbers we're using for the y's. What are we using for y? Well, I have a 2 here. I have a 3. I'm using a 4. How about this 5? And also a 9. What's the inverse? All we do is just flip the coordinates. So I'm going to have 9, 3. 2, negative 3, 4, 4, 5, 3, and 3, negative 4. Is this a function? No, because the 3 here and here being listed twice, it's no, because it's listed twice, right? Find the solution set of 4x minus 2y is equal to 8 given the replacement set. 2, 2, 2.5, 1, and 1, negative 2. That means plug these coordinates in for the equation and see what happens. Do you get the left side equal to 8? Let's take a look. In number 33, like we were saying, we plug in 2, 2 in for the x and the y. You get 8 minus 4 is equal to 8, which doesn't work. 4 times 2.5 minus 2 times 1 is equal to 8. That does work. 4 times 1 minus 2 times negative 2, that's 4 plus 4 is equal to 8. That works. It is not good enough to sit here and try to circle these. It's the difference between thinking you know and knowing you know. Prove to us, prove to your teacher, you know what the solution is and write it down. It's the points 2.51 and 1, negative 2. In number 34, make a table. Solve this equation when x is equal to negative 1, 0, 2, and 4 means to make a table. So let's do that. And here's your table. When x is equal to negative 1, you get y is equal to 8. When x is equal to 0, y is equal to 6. When x is equal to 2, y is equal to 2. And when x is equal to 4, y is equal to negative 2. Well, how did we come up with that? Well, the first thing you need to do is take this equation and solve for y, because whatever y is equal to, that's what goes into this second column. It's negative 2x plus 6 that we put in here. Plug in all those x's, come up with your y's. There's your table. Good luck on your test. We'll see you next time.